Good morning, children. Today, let us recall certain concepts about functions. You have studied about functions in standard 9 and 10. First of all, what is a function? We should know two sets for it. F is a function from A to B. The first set we call domain and the second set we call codomain. These are called elements. These are called images. This I can also call pre-image. Range. Range is a subset of the codomain. Whichever is marked, these images alone I will write as a set. So what is the domain for this particular example? A, B, C. Codomain 1, 2, 3, 4. Whereas range is only 1, 2 and 3. 4 is not mapped. So 4 will not come under range. Now when will you say it is a function? Every element in the domain should have an image. Every element in the domain should have an image. And one element should not have two images. See, you are the element. Stand in front of a mirror. If there is no image in the mirror, it is wrong. Yes, so that is not a function. So no image tells it is not a function. And this is another idea. You stand in front of the mirror. You see two images, two of yours. That is also not normal. So when you stand in front of a mirror, you must see only one image of yours. So the image should be unique. You are an unique person. So the image should be unique for the function to be a function. Now, some of the types of functions that we have learnt already. Many elements will go to same image. See, we have twins at home. We have triplets at home. Two children may have same image. That is the idea. A, B are having same image. Many elements have same image is called many one. Suppose every element goes to only one element. That is, I will say different elements have different images. A to 1, B to 2, C to 3. This we call one-to-one function. Every element has a different image. The images are not same. That case, I will call it is one-to-one. There is yet another thing, identity. Your identity card will have only you. So A goes to A, B goes to B, C goes to C. If I have something more, 1 goes to 1, 2 goes to 2. So same element and images are same. That case I will call identity and I will write it as f of x is equal to x. Or in other words, I of x is equal to x. I stands for identity. Constant. What does the word constant mean? Constant means no change. So all the elements will go to same image. A goes to 4, B goes to 4, C goes to 4. So all have same image. I will call the function to be constant. F of x is a constant. F of x equal to C. F of x equal to K. In this question, f of x is equal to 4. Whatever may be x, my answer is only 4. So that is called constant function. Now, if a function is one-to-one and onto, what do you mean by onto function? We mean onto function says nothing remains in the codomain. See, this is into function. This is into function. How will I make it onto? Onto function says A set is having A, B, C. B set may have 2 and 3. This 2 goes to 2 and C goes to 3. Nothing remains in the set. I will call it is onto. Now, whenever a function is 1, 1 and onto, we give the name bijective function. Bijective function tells me the function is 1, 1 as well as onto. In that case, we define f inverse. We call this as inverse of f of x. In the exercise, we do problems based on that. F composition f inverse is I, we say, or f inverse composition f also we say I. Composition is an operation in functions. Functions we can add, subtract, and we can also find composition of functions. We even have multiplication and division. Special operation in functions is composition. We put a small circle whenever f and f inverse are there. F inverse. How do I read it? F inverse. F composition F inverse gives me I. What is I? I is the identity function. When exercise problems come, let us discuss in detail. Now there are some more new functions. Function we call modulus. What do you mean by the word modulus? Modulus tells me it is a magical box. I put positive number in, my answer is positive. I put negative number also, my answer is positive only. See, this we call modulus. I put 0, my answer is 0. I put 1, it is 1. Minus 1 I put also, my answer is plus 1. I put 2, my answer is 2. I put minus 2 also, my answer is plus 2. So how am I to draw the graph of it? 0, 1, it is 1. Minus 1 also, it is 1. 2, it is 2. Minus 2 also, my answer is 2 only. Mark it all using the diagram. Join it like this way. For negative also it is positive. For positive also it is positive. So this we call modulus of a function. So modulus is always in first and second quadrant. Here only. It will not come down. Y is not negative at all. So y we call mod x. My answer is always positive. There is another function called signum. Signum function, I write x by mod x. Suppose I put 7. What is f of x? 7 by mod 7, my answer is 1. Suppose I put minus 7. F of x equal to minus 7 by modulus of minus 7. Minus 7 by modulus of negative number is positive. So my answer is minus 1. So signum function gets only 3 values. When x is 0, I cannot divide. Remember, in mathematics, 0 should not come in the denominator. So whenever you have something in the denominator, immediately ensure it mustn't be 0. So signum function exists only for x not equal to 0. Whenever x is 0, I will declare the function to be 0. Now, when x is positive, see what is my answer? 1. I put 7, 8, 1, 2, 3. My answer is 1. Whenever I put negative numbers, my answer is minus 1. So for all the positive numbers, my answer is 1. So for all the numbers, my answer should be plus 1 only. Remember, it goes on and on. For all the negative numbers, my answer is minus 1 only. Whatever may be x value, 1, 2, 3, 4, anything. My answer is only plus 1 if it is positive, minus 1 if it is negative. And when it is 0, my answer is 0. Remember, the line should not touch here. It is an open circle, means it doesn't touch. Because we know the answer is 0 for 0. For all the other numbers, positive numbers, it is plus 1. Negative numbers, it is minus 1. There is some more function we call greatest integer function and least integer function. What do you mean by this word greatest and least? See, there is a sketch pen. This sketch pen, where is it if I ask you? What will you tell me? It is above the paper, one way I can say. And it is below my hand, I can say. Suppose my hand is here. So this sketch pen is above the paper and below my hand, like that. Every number in maths, I can say it is above an integer and it is below an integer. For example, see this. 2.3. I can say 2.3 is above 2 and I can say 2.3 is below 3. So greatest integer function tells me, see the left number. So this I call greatest integer. Whereas this number I call least integer. So I will say 2.3 is above 2. So greatest integer is 2. And I can also say 2.3 is below 3. So the least integer is 3. So look at the examples. When you have 0.5, 0.1, 0.3, any number in 0.1, 0.2, 0.3, all that, my answer is 0 only. So from 0 to 1, all the decimals, my answer is only 0. Once I cross 1, for 1 it is 1. Once I cross 1, 1.1, 1.2, 1.3, all will come under 1 only. 2.1, 2.2, all will come under 2 only. Once I cross 3, my answer is only 3. Once I cross 4, my answer is only 4. See, there is a break. And we call this as a step function. Also, it looks like a step. So, we call it as a step function. But there are two cases. Here there is a step, here there is a step. So, we call this as a step function. Means this we call floor function. The least integer I call step function. This one I call floor function. See the change. Both are looking the same only. But 0 to 1 I consider 0 here. 0 to 1 I consider 1 here. That is the change. 0 to 1 I consider 0. 0 to 1 I consider 1. So every time you are given questions like this in objective type, you must know what you are going to answer. If it is greatest integer, see the left side number. And if it is least integer, see the right side number. For 0.5, this will be greatest integer and this will be least integer. For minus 2.1, this will be greatest integer. Remember, I must see only the left side. And this will be least integer. So, you are mostly given a problem from this in one word. So, these two we call greatest integer and least integer functions. So, this particular functions topic, mostly the concepts are repeated from standard 10. Now, we go on to certain special functions. What do you mean by this word? Linear. Linear tells me degree is 1. So, I will write ax plus b. F of x equal to ax plus b. X power 1 only should come. It is defined for all x. So, I can say f is a function from R to R we can define. When it is a quadratic function, we write like this way. The power is 2. Remember, this also we have studied in 10th. F of x equals to ax square plus bx plus c. What is the power? 2. So, highest degree 2 we call quadratic. When the highest degree is more than 2, we can also call cubic, by quadratic, all that, or in general polynomial. See, a0 x power 0, a1 x power 1, a2 x power 2 and so on, an x power n. So this is a polynomial of power n. So the degree is n when an is not equal to 0. So here also I can say they are all functions from R to R. R stands for real numbers. Real numbers to real numbers. When I go on to logarithmic, I define like this. Logarithmic, I can say log x base can be any number, 2, 3, 4, all that I can define. Remember, logarithm when I defined, it must be from positive value only. Log is not defined for negative values. Log is defined only for positive values. So it is from 0 to infinity to R. Now look at the example. We are seeing y equals to log x base 2. How should I draw? 2 base 2, my answer is 1. So log 1 is always 0. Log 1 is always 0, remember. 2 base 2 is 1. So 2, 1 I have to mark. So the diagram goes like this way. Similarly, I can draw log x base e, log x base 3, all that. It will be one below the other, and this side it will go near and near but never touches y-axis. It goes on, and my answer is infinity when it touches. Now, what is the reverse of logarithm? We call exponential function. Here I have log x, here I have x in the power. The same diagram, the reverse. This is in first and fourth quadrant. Log is not defined for negative values. Exponential, my answer is always positive. Even if I say 2 power minus x, I can say 1 by 2 power x. So exponential function is always positive. It is only in first and second quadrant. See, your diagram goes like this. When I draw, and this also touches at 1 only, and it goes like this way. The remaining we can draw like that. And remember, when it is 2 power x, it will be near x-axis. When it is 3 power x, it will go away from x-axis. So as the number increases, it will be away. So this is 3 power x. E is a number between 2 and 3. You should have studied in lower class, but hereafter we will come across this often. So E is a special irrational number between 2 and 3. E will come in between here. So next number is 3 power x. Next number 2 power x will be somewhere here. E power x will be somewhere here because it is between 2 and 3. As I increase the number, it will go near y-axis. 2, 3, 4, 5, 6. It will go near and near y-axis. The next important function is e power x and e power minus x. E power x, here we have done same thing, we will draw here. This is e power x, let me say. and this is just the reverse of it, e power minus x. And notice all these curves will go near and near. We don't touch it. We assume they touch at infinity in a long distance. So this I call e power minus x. So these are some special functions. When they come again and again in exercises, we'll see in depth. The next idea, exponential function. Now that you can give an example, it is f of x is equal to 2 power x I can say, or e power x I can say. So these are examples. And what did we see in the diagram? Exponential function from minus infinity to plus infinity, they exist. So it is real number, but my answer is only positive. So I will say f is a function from real numbers to 0 to infinity. Rational. What do you mean by this word rational? Some function in the numerator, some function in the denominator. I can give you an example, and remember, denominator must not become 0. So whenever you are writing any function or anything in the denominator, ensure it is not 0. Some example you can tell me, x plus 1 by x minus 5. Immediately I should write x not equal to 5 because denominator should not become 0. Reciprocal function. It is just 1 by f of x like that. So 1 by x, 2 by x, all these things we will say reciprocal function. Odd, very important one. Wherever x is coming, I put minus x. Sign changes. It is called odd. Sign does not change. It is called even. See, x, x cube, x power 5, all these are odd functions. Whereas x square, x power 4, x power 6, all these we will call even functions. Again in exercise we'll see in detail. So let us remember, wherever x is coming, I put minus x. Sign changes, it is odd. So x, when I change minus x, my answer is minus x. Sign changes, so odd. But x square, even if I put minus x the whole square, my answer is positive. So powers are even, we declare they are even functions. Powers are odd, we declare them to be odd functions. And in trigonometry, we will study in detail about these things. The next idea, we are going to say tests of an function. Vertical line test, we have already learned. This test is to check whether the given is a function. So I draw a vertical line cutting at 2 points. The line cuts at 2 points implies it is not a function. So this particular idea is not a function. Whereas here, anywhere I keep and draw a line, it cuts at only 1 point. See? This cuts at only 1 point. So this is a function. So yes. What about this idea? I draw a vertical line. It cuts at only 1 point. So this is also a function. So these two I call yes, they are functions. But this I will say it is not a function. Coming up to horizontal line test. This is called horizontal line. When I draw a horizontal line, see here also I am drawing one, here also I am drawing one. This horizontal line test helps me to check the given function is 1, 1 or onto or not. Now x is the domain I call and y is in the codomain. So y values are in the codomain, x values are in the domain. So there is a codomain value y in which I draw a horizontal line. Does it touch the curve? The line does not touch the curve. So this I will say not onto. So whenever a horizontal line from a point in the codomain I draw, if it does not touch the curve, I will say this is not onto. Whereas come here, we have drawn a horizontal line. Wherever I draw, it cuts at only one point. So this I will call onto 1 function. Here, whenever it is cutting at more than one point, the line cutting at more than one point, I will say not 1. So cuts at only one point, I will say it is 1. Cuts at more than one point, I will say not 1. Does not touch at all, I will declare not onto. Let us remember, line does not touch at all. Horizontal line does not touch the curve. It is not onto. Touching at only one point, it is 1. Touching at many points, it is not 1. So functions is a little abstract concept, but many of the concepts that we have learned is from 10th standard. Exercise problems will be simple. We'll do that in the next class. Thank you.